write cot square as 1 plus cot square theta. Watch the rules there. 1 plus cot square is cosec square. So that's cosec square minus 1. Right? So plus cosec square x minus 1. Don't forget that 2 please. There is a 2 also. And integration bracket dx. And we know how to do this now. Let's collect the like terms before we apply the rules. So we have sec square x and plus cosec square x, then we have minus 4, watch there, right, bracket dx, and now we can integrate very easily. Right guys, so sec square integration is nothing but tan theta, isn't it? So that's a tan x. Now cosec square, just be careful, cosec square integration is minus cot x please. So that becomes a minus cot x. Reverse of chain rule is not there, so minus 4 with respect to x is 4x and plus c. So that's how we can leave the final answer. No simplifications needed there. Okay, so we just opened the brackets. The objective was to change everything into the standard functions, right? Then this is the next question for you. Now before I teach this, I want you to just go back to C4 or C3 trigs. I told you to copy all the rules at one place, please. That's very, very important. I'll take you through these 4 rules now. These are called factor rules. In other words, if the question is sum of 2 sine functions, you can write that as a product of sine and cos. Okay. So same thing for sine. If it's minus, that's a cos and sine. These 4 are in your book. Some textbooks have P and Q, some have A and B, and some books have C and D. So be very careful, please. Copy them at one place. Now what happens here? The question looks like, let me call this as a C, say 2 sine A cos B like. Now sine and cos. So go and see where is the sine and cos. 2 sine cos. So we have 2 sine cos. So c plus d divided by 2 supposed to be the 4x. And c minus d divided by 2 is 1x. Okay. If we know what is c and d, we can substitute there. So this can be expressed in this form. Then we can integrate. So that's the plan, right? So please understand, c plus d divided by 2 equals to 4x or 4 there, right? And c minus d is 1, all right? So that's 4x and c plus d is a 4. Suppose ignore the x, let's just say 4. And that's going to be c minus d divided by 2 equals to 1 like. So c minus d is equals to 2 times 1, 2. That's 2 times 4, 8 please, right? We solved those two simultaneously to find what c and d are, right? After that, I will teach the shortcut for that. So c plus d is 8, c minus d is a 2. Simultaneous, we know 2c is a 10 and c equals to 5. Substitute back, we are supposed to get d as a 3. Okay, so those are the two values of 5x and 3x. The shortcut is actually when you add those two, 4x and x, you're supposed to get c, which is a 5x, and subtract that from 4x. 4x minus 1x should be a 3x, that's a d. So we know what is c and d, so we can write the given question like sine c plus sine d. So then we can integrate. So what I do, I'll change that whole thing now as a sine c plus sine d. Sine c plus sine d integration. C we know as a 5. Okay, so let's write that down. So it's a sine 5x and plus sine 3x. If you want, you expand it, you will get that using the same rule. Now that's integration, we know, and we can integrate both of them now. Dx please, and reverse of the chain rule, don't forget, please, right? So sine 5x, it's a 5th. Sine theta integration please, so it's a minus cos theta, that's a 5x. that also will be minus. Reverse of the chain rule, right, 1/3, and sine becomes a cos, 3x, and plus c. So that's how we leave the final answer there. Very, very important, the factor rules, please. 2 sine something cos something. It's a times sign between them. So you got to go and see, is the question looking like this, the right hand side? Once you see all those, if you learn them, it's pretty easy. Let's look at the second sum, right? It will be more or less same, but I will show you how to recognize which pattern it is. 2 is a 2, cos and a sine. First one is cos, second one is sine. Very important, right? So let's look at the rules we have. First one is cos and second one is sine. So that's what we have. 2 is already there. If 2 is not there, you can actually introduce a 2 and then times by half. So our question actually is 2 cos c plus d divided by 2 times sine c minus d divided by 2. So we don't need to use the simultaneous equations to find c and d. We can simply say c is equals to, here 5x plus 2x, 7x, and d is minus that from that, please. 5 minus 2, it's a 3x. So that's all. And don't forget, look at the left hand side also. So this can be expressed as sine c minus sine d, right? So we will write that now, which is integrate sine c, which is a 7x, minus sine d, please. So that's a 3x. And dx, we know how to integrate this, right? Wantedly, I just chose straightforward sums first so that we will understand it, right? So that's a minus 1/7 of cos 7x, and minus, that's a minus, so it's a plus, please, and 1/3 cos 3x. Okay, integration of sine is minus, so that minus becomes a plus and plus c. So those 4 rules are very important. I'm looking at the next one, which is another one. So we have a cos and a cos. So recognize the rule. They are given in the examination, right? So I have double cos there. 2 is already in the front. So there we go. That's a cos and cos, right? 2 cos c plus d over 2 cos c minus d over 2. That's how our question looks like. So the answer should be cos c plus cos d. We got to know what's c and d, please. C is equals to 7 plus 4, which is 11x. Add them, very easy. And d equals to 7 minus 4, 3x. That's the shortcut, or you just want to use the simultaneous equations, it still can be done. So the answer now is cos, so please watch, cos c plus cos d. So I will write cos c, which is 11x, plus cos d. Be careful about the signs there. Cos d is a 3x. Bracket is closed, dx comes back. Now, integration, we know that's 1 over 11 sine 11x, right? And plus cos theta is sine theta, we know, 3x, and 3x is 1/3, reverse of the chain rule, and plus c. So those 4 examples, I mean, I just took one for each one for you to see how that is applied. The next one, question 15, both are sine now, right? Sine 2x, sine x, that's a times sign. There is a minus 2 in the front. Let's go and check. Do we have that type of rule? Yes, we do. Minus 2, sine, sine, watch there, right? So the answer is actually cos c minus cos d. So let's write cos c. Well, we need to know what's a c first. C is at 2x plus x, 3x, and d should be 2x minus x, which is 1x. Okay, so the answer now is, in fact, integrate cos c, cos 3x minus cos d. That's a cos 1x, or just x. Dx comes back. We didn't integrate yet. Okay, now integration comes. That's going to be cos theta is a sine theta. So simply sine theta is 3x, and reverse of the chain rule. Minus cos x, so simply sine x. No number in front, so that's divided by 1 like. Okay, that's a sine, please. Plus c. Okay, 4 rules, very important. They are in the textbook, right? Just copy them at one place. Study the structure of the sum. It should be cos, cos, sin, sin. Then you have sin, cos, and cos, sin. C and D, how to find, just add them to get C, minus the second one from the first to get D. There are many ways to actually see how to find the C and D, or P and Q. One more to go of the same type, but a number is missing in front. Let's see how that is done. There is no number in front. So there is a times sign, so we are happy. That's a sine and cos. So let's go and check. First is sine, second is cos. That's very important, the order. Sine and cos. So we need a 2 in the front. So insert a 2 and multiply by a half. That makes sense, isn't it? So that's 2 sine C plus D over 2, cos C minus D over 2. The answer is sine C plus sine D. Okay. C equals to 3 plus 2, 5x, and D equals to 3 minus 2, 1x. Then we say half is a half, integrate. That can be written as sine C, which is 5x, and it says plus sine D, so sine 1x. If you expand it using the same rule, you're supposed to get the question back. Dx, the integration now we know, easy. Inside the bracket, that's a fifth, right? 1 over 5, sine theta is minus cos theta, please, right? Minus that, and minus that again is cos x. We multiply the bracket with a half to write the last step. That's a minus a tenth and cos 5x. Then half, so it's a minus a half cos x. Then finally plus k or plus c. All right, they are indefinite integrals. Be very careful. Right, so we completed the trigonometric standard functions, how to use them up to now, say, right? We did 16 sums. The last 4, just be careful, right? This next part now is going to be something called guessing method or recognition style. I mean, there are so many names for that. When you study a question, when you see the question, you can easily tell the answer by looking at the sum or by doing a little bit of work, okay? That's the next part, okay? That's how it looks. It says, so we are looking at some kind of a pattern in the question. If the question looks like function x, means some kind of function there, to the power square, cube, 4, whatever, and if you differentiate this, suppose you got that. So there are two functions, there is a times sign between them. Now this is one type of style you will see in the examination or the textbook. Before we understand that, let's just solve a question based on that. Then I will explain what actually is happening. So let's study this. This sine square x looks like function x square. So I will write that as a sine x and a bracket and a square. So that looks like this now, right? Times whatever is inside, if you differentiate, you're supposed to get that. So differentiate the sine x, we get cos x. That's all, right? So cos x is already there. That's it. So if the question looks like this, what they said was, they want us to try, it's trial and error method. They want us to try y equals to, means let y equals to sine cube x. Just increase that power by 1, so sine cube x. Then they said, okay, take that and find dy over dx, see whether you get the sum back. So dy over dx is equals to sine cube x, please, which is 3 sine square x, okay, 3 sine square x times chain rule, we have to differentiate the sign, we get a cos x. So what they are saying to us now is, if you differentiate that, you get this, right? Great. So if we integrate this, we are supposed to get that. That's what it means. So see whether your question looks exactly the same way or not. If it's exactly same, that is your answer. I can easily see, or you can see, there is a 3 missing. Sorry. So write the 3 in front. So that looks exactly same as this now. And then multiply by a third. Okay. So 2 things, please. Very important. I have a question. Y equals to blah, 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 right? I find dy over dx. I got something else. What we are saying is, because you differentiated this to get that, if you integrate this, you're supposed to get that. So that's what it means. That's what they are saying to us. So the answer now is nothing but whatever you chose. Well, there is a third, okay? So it's 1/3 comes back and then sine cube x. Sine cube x plus c. Okay, these are called guessing style or recognition style. If you take this now and actually find the differentiation, you're supposed to get the sum back. That's what they are saying. If you don't understand this, right, just bear with me. Take one more question, see what happens, right? So the question should look like that. That's what they are saying. So I got a bracket, great, and I do have a power 4. That's great. Okay. What I need to see is, if I differentiate the bracket only, I'm supposed to get whatever is here. If a number is missing, doesn't matter. We can introduce that number. So let's go and check. If you differentiate this mentally, we are supposed to get a 2x, right? So there is x here. Only 2 is missing. That we can deal with later. So what we are saying, the question is in this pattern. That's what it means. So the method says, all right, let's guess the answer. And say y equals to, take this bracket, x squared plus 5. Instead of to the power 4, you say to the power 5. Just increase that power by 1, please. That's what they meant. Once you choose this, let's see whether we are right or wrong. So differentiate on both sides with respect to x. dy over dx equals to this, 5 comes to the front, bracket to the power 4, x squared plus 5. Chain rule, we need to differentiate the bracket. So differentiation of the bracket comes as 2x. So the final step, when you simplify that whole thing, you're supposed to get 10x and bracket x squared plus 5 to the power 4. So is this our question? If that is the question, whatever I chose here should be the answer. That's what they meant. All right, we compare it now. We got a 10x, but we don't have a 10 there. So introduce a 10 and divide by a 10. All right, done. So what is the answer now? Means the 10th comes back and whatever you guessed, bracket x squared plus 5 to the power 5 and plus c. So that's a guessing style, but I would like to say it's a trial and error, doesn't matter. Okay. If you feel, oh, I'm sorry, I didn't understand, means let's just take one more and then see. We prepare, you and I, right? I'm taking my own sum here, sorry, with your help. So I will write that bracket first, that one, whatever, right, guys? So let's say integrate, leave that space, put a bracket, say I have x cube plus 1 to the power 7, for example, right? So this looks like function x to the power 7. So if I differentiate this, I'm supposed to get that. So let's go and differentiate the bracket. It's a 3x square. So don't write 3x x square. Let's write only x square to see what happens. So we need to guess now. Guess the answer, right? So we say, right, let y equals to the bracket, which is x cubed plus 1, close the bracket and increase that power by 1. Because when you find dy over dx, you get that 7. That's the idea, okay? dy over dx, 8 times bracket to the power 7, right? X cubed and plus 1. See, that's what we meant. That's the reason we increase that power by 1. And please don't forget chain rule, so you differentiate the bracket, which is 3x square, right? All in all, in the end, we end up with 24x square and bracket to the power 7, that's x cubed plus 1. So what we are saying, if that was my question, my guess, that should have been the answer. So that's the plan. So there is a 24 missing in the question. So you introduce a 24 and divide by a 24. That's all you do. Okay. This works for trigs or algebra, whatever. And now what's our answer means? We still need to write the answer, please. Don't forget, right? The answer is now the 1 over 24 comes back and the guessed one, which is x cubed and plus 1 to the power 8 plus c. Okay, we did that. A similar question we prepared and solved again. Okay, these sums are based on that kind of a pattern. So there should be a times sign, two functions. If you differentiate that, you should get that. That's all. If we take one more, let's see. I'll do one with trigs in a minute. Algebra, right? So it's a 2x cubed plus 1. We have x squared to the power 7. Hey guys, I think what we guessed here, say the sum that we both prepared here is more or less same. So I will leave this question with you to do that. Okay, copy that and solve, please. Then number 3, let's take another one which is on the screen here. It says cos 3x 1 plus sine 3x whole cube. Does it work for trigs? Let's see. This looks like function x to the power n, isn't it? So that should have been f dash x, right? So let's differentiate the bracket. Differentiation of sine theta is cos theta. Done. Well, reverse of the chain rule or normal chain rule, we talk about it in a minute. So we copy this now and say our job is to guess, right? Let y equals to, we take exactly the same bracket, say 1 plus sine 3x and to the power 4, we increase that by 1, right? 3 plus 1. And now differentiate. So it's dy over dx is equals to 4 times bracket to the power 3, right? 1 plus sine 3x inside, and then times, we use chain rule and we differentiate the bracket. Sine theta is cos theta, okay? But please listen, you have to differentiate the 3x as well. Using the chain rule, we have a third. 3, right? Times 3. Now, the final step looks like 3 times f4. Hey, don't say 3 times 3x is 9. That's a number, please. That's an angle. 3 times f4, 12. Let's write cos 3x in the front, right? Cos 3x. And then inside the bracket, whatever is there. 1 plus sine 3x and to the power 3. So compare the question now. The question is more or less same except this number. So introduce the 12 in the front. Then divide by 12 there. Okay, so what's the answer? The answer is now, the 12th comes back, right? The answer is a 12th and the guessed part, which is inside the bracket 1 plus sine 3x to the power 4. That's what we guessed to get the answer, right? So that's how you do these sums. Maybe we take one more question now. What if I have a question like this, say, so let's use trigs. Let's write tan theta, right? Tan theta d theta. Differentiate tan, sec square. Let's write sec square theta in front. So it's sec square theta times tan theta d theta. So that's a function x to the power n like, and this is f dash x. But it doesn't look like to the power n, but watch out, there is a 1 there, isn't it? Tan to the power 1. So now How do you guess the answer? Say, how do you start? Means you say let y equals to function x, we increase that power by 1. So let y equals to tan square